Alternative is, suppose L of x comma y is equal to 0, be a straight line, be a given straight line, and ax1 y1 are two given points, ax1 y1 and bx2 y2 are two given points. Two given points. Now, what I do is, suppose A and B are the same side of the line, for example, I am considering. So what I do is, this is the line. Suppose A, B are same side of the line. Suppose A is x1, y1 is over here and B, x2, y2 is over here. So if both the points lies on the same side of the line, then we will see the condition. Already we know L of x1, y1 into L of x2, y2 is positive. Already we have seen yesterday in another way. So in this method, what I do is, to find this one, I will join this AB, line joining AB and this line. So this line joining AB intersect this line, sorry, given line at some P. So this line is what given line, that is L of x comma y is equal to 0 line. So the points ax1, y1, what I have done, I joined this AB and extend this line such that it meets the given line at P. So then what you do is, now let the point PB, P divides, suppose let point P divides A and B externally in the ratio of k:1. Yes, sir. Let P divides, so A comma B externally in k:1 ratio, externally in the ratio of k:1. Now that implies, the meaning of that one is AP by PB is equal to what? K by 1, external division. Now you write the coordinates of this Px comma y, external division point. So that is ax1 y1, bx2 y2, and ratio is what? K:1. External division, this goes to this goes to this side. Therefore Px comma y coordinates are what? External division, mx2 minus nx1, that is kx2 minus 1 into x1 by k minus 1. Next, ky2 minus 1 y1 by k minus 1. So that is equals to kx2 minus x1 by k minus 1, ky2 minus y1 by k minus 1. So this point is Px comma y, external division point. Now this Px comma y lies on this L of x comma y equals 0. Therefore, this lies on, suppose L of x comma y is equal to 0 is, you take this line equation as ax plus by plus c equal to 0. This is the line. So this lies on ax plus by plus c equal to 0. Then it must satisfy, that is a into kx2 minus x1 by k minus 1 plus b ky2 minus y1 by k minus 1 plus c is equal to 0. From this one, what you get? Therefore, a into kx2 minus x1 plus b into ky2 minus y1 plus c into k minus 1 is equals to 0. Now this implies, so here rearrange the terms, then so from these three terms, from this term and this term and this term, k common, then what can you write? This is equal to k into ax2 plus by2 plus c. So minus remaining terms are what? Minus of ax1 plus by1 plus c is equals to 0. So this implies from this one, if you isolate k, the k is equal to ax1 plus by1 plus c by ax2 plus by2 plus c. So now k is equals to, what is this ax1 plus by1 plus c? L of x1 y1 by ax2 plus by2 plus c is L of x2 y2. So, but in ratio k is to 1, means k is a positive quantity or not? Suppose ratio is 2 is to 1, 2 is a positive quantity. Yes or no? K never be negative. Since k is a positive quantity, that implies L of x1 y1 by L of x2 y2 is positive. So L of x1 y1, L of x2 y2 positive. Therefore, now what you do is you multiply this with both sides multiply by L of x2 y2 whole square. So we are multiplying with a positive quantity, therefore inequality remains same. L of x1 y1 by L of x2 y2, you multiply with L of x2 y2 whole square both sides, because we are multiplying with positive quantity, therefore inequality remains same. If you multiply with negative quantity, inequality alters, changes. So now what happens? This L of x2 y2 one time cancel. This right hand side anyway 0 only. Therefore L of x1 y1 into L of x2 y2 is greater than 0. So this is the condition for the 2 points lies same side of the line. If 2 points lies on the same side of the line, then L of x1 y1 into L of x2 y2 is positive. Yes or no? In previous method also we got the same thing. Clear?
Yes, sir.
Right. Similarly, if the 2 points lies opposite side, then internal division formula. Is or not? So similarly, we'll write that one also. Similarly, suppose the scenario is this one. Suppose this is the line. This is L of x comma y is equals to ax plus by plus c equal to 0. Suppose one point is this side ax1 y1 and the other point is bx2 y2. Then to find the condition, join this a and b. Now this point px comma y is what? Internal division, k is to 1. So if you use internal division formula, then similarly px comma y is equals to what? kx2 plus x1 by k plus 1, ky2 plus y1 by k plus 1. So this px comma y lies on ax plus by plus c equal to 0. So it must satisfy, therefore a into kx2 plus x1 by k plus 1 plus b into ky2 plus y1 by k plus 1 plus c is equals to 0. This implies a into kx2 plus x1 plus b into ky2 plus y1 plus c into k plus 1 is equal to 0. So similar to previous one, if you take out k common, ax2 by2 plus c plus ax1 plus by1 plus c is equal to 0. So from this one, if I isolate k is equals to minus of ax1 plus by1 plus c by ax2 plus by2 plus c. Since k positive, yes sir, since k positive means right hand side must be positive. Therefore minus of ax1 plus by1 plus c by ax2 plus by2 plus c must be positive. Means ax1 plus by1 plus c by ax2 plus by2 plus c must be negative. So, so similarly, if you take out k common, ax2 by2 plus c plus ax2 by2 plus c must be positive. Means ax1 plus by1 plus c by ax2 plus by2 plus c must be negative. So, similarly, if you take out k common, ax2 by2 plus c plus ax2 by2 plus c must be positive. So No, same. This is nothing but L of x1 y1 over L of x2 y2 is negative. Similar to previous one. Multiply both sides with L of x2 y2 whole square. It's a positive quantity. L of x2 y2 whole square by L of x2 y2 is greater than 0 into L of x2 y2 whole square. Then what you get? This one time cancel. L of x1 y1 sorry, less than 0 this is. So this is less than 0 into L of x2 y2 whole square. Therefore, this L of x1 y1 into L of x2 y2 is negative. Therefore, this is the condition for if the 2 points lies either side of the line. Then L of x1 y1 into L of x2 y2 is negative. Clear? This result.